Good morning, students. This is Mrs. Avila presenting your lesson for Monday, April 27th for Rio Rancho Middle School, Earth Science with Mrs. Avila. All right, so here's your week at a glance. On Monday, we're doing lesson 1.5 titled Evidence About Gases in the Atmosphere. On Tuesday, you're going to take a Chapter 1 quiz. You will be able to use the key concepts that we provide for you to do this practice quiz. On Wednesday, we're doing lesson 2.1, which is titled Introduction to Energy Entering and Leaving, Part 1. On Thursday, you're doing Part 2. And on Friday, you're doing Past Climate Changes on Earth article and questions. So, week meme, or meme of the week, not even sure what day it is anymore. Feels like it must be at least April 94th. You saw that the end of the week is May 1st. It's crazy to think that we're going to be in May. When we last saw each other, it was March 13th. So crazy times. Right, so for Monday, April 27th, our agenda is lesson 1.5, Evidence About Gases in the Atmosphere. Our essential question today is what kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface. And what we're going to do today is lesson 1.5, Evidence About Gases in the Atmosphere assignment. So you will need to have this Screencastify video and the lesson 1.5, Evidence About Gases in the Atmosphere assignment open. Meme of the day, remember back when we were all super judgy about Anna and how she was so desperate for connection after like 10 years of quarantine? Yeah, me too. Not so judgy anymore, right? All right, so going to our lesson. This is what the document that you need to have open today looks like. Again, it's titled Evidence About Gases in the Atmosphere. Has the essential question again. What kinds of changes to the atmosphere could affect how much energy is absorbed by the Earth's surface? Excuse me. So sorry. That's what happens when you do your lessons at 3 a.m. Right, so you're going to have this document open and ready to type in your answers as you watch the lesson video. Okay, so warm up today. Earth's atmosphere is a layer of gases that surrounds the entire planet. Each gas in the atmosphere interacts differently with energy. Each gas may absorb energy, reflect it back to where it came from, or let it pass through. Yesterday, at the end of our lesson, or on Friday at the end of the lesson, we read about the ozone layer, and we also watched a little video. And here's a quote from what we read. Scientists found the hole in the ozone layer has caused an increase in the amount of UVB light that reaches Earth, which has had health effects for humans and other species such as skin cancer. However, UVB light is less than 1% of the energy from the sun. So the increase in UVB caused by the ozone hole is not significant enough to raise global temperatures. So highlight the one or ones you think answered the questions. Based on what you read, what is true about gases in the atmosphere? So to highlight, I'm going to show you how to highlight again. You're going to press on the 3 dots here, and this is your highlighter button right here. You can click it whatever color you want. But first you have to select the text that you want to highlight. So based on what you read, what is true about gases in the atmosphere? First one, all gases in the atmosphere affect energy the same way. Second one, different gases in the atmosphere affect energy differently. Third one, no gases in the atmosphere affect energy at all. Fourth one, ozone is the only gas in the atmosphere. So whichever one that you believe to be true, you are going to select it. If you think this one is true, you're going to go to highlight it, and you're going to press highlight in order to get that highlighted, okay? I'm not giving away answers here. You're going to put your answer that you think is true based on the reading up here, which I just read to you. Okay, number 2, based on what you read, what is true about the ozone hole? First one, the ozone hole causes warmer global average temperature. Second one, the ozone hole causes cooler global average temperature. Third one, the ozone hole does not affect global average temperature. Again, you're going to select whichever one you think is correct. Press the highlight button and choose whichever one you want to highlight. Okay. The simulation provided evidence that changes to carbon dioxide, methane, and sulfur dioxide could increase temperature, but we need to find out if these gases have in fact changed in the atmosphere over time. So we're looking at increasing carbon dioxide, increasing methane, and decreasing sulfur dioxide, which could potentially warm up the Earth, increase temperature. Let's compare graphs from the SIMS with graphs of carbon dioxide, methane, and sulfur dioxide to see if they support the claims up above. Claim 1, increasing carbon dioxide causes increases in Earth's temperature. So these are graphs from the SIM. So this graph here is showing on the x-axis the year, and on the y-axis the concentration in parts per million of carbon dioxide. So this goes from about 1880 all the way to 2010-ish. And this is data out there in the world, and this is from our SIM. We see that when carbon dioxide increases, which looking at this graph, the overall trend is that carbon dioxide has increased. We see that when carbon dioxide increases, the temperature increases, the amount of absorbed energy increases, and the surface ice decreases. It actually melts. The graph on the left is showing what is actually happening, finding all kinds of typos, actually happening with carbon dioxide levels on Earth from 1880 to 2018. You can see that there is an upward trend in the levels of carbon dioxide. Get rid of that. The graph on the right is from the SIM when carbon dioxide was increased. Increasing carbon dioxide did the following. Earth's surface absorbs more energy over time, which was the yellow line. Temperature is increasing over time, which is the black line. And the amount of ice on Earth's surface decreases over time, and that's the blue line. The claim is supported with evidence from the SIM and matches the graph of current carbon dioxide data. Increases in carbon dioxide cause Earth's surface to absorb more heat, which causes the Earth's temperature to increase. This leads to ice on Earth's surface to melt. Okay, now looking at claim 2, which is increasing methane causes increases in Earth's temperature. So we could definitely say that claim 1 is supported. Increasing carbon dioxide causes increases in Earth's temperature. So looking at claim 2, increasing methane causes increases in Earth's temperature. So here we have graphs again. This one is methane. X-axis is showing year. Y-axis is showing concentration in parts per million. We're seeing the overall trend is that methane has increased in the Earth's atmosphere from 1880 to 2010, has an overall trend of increasing. This is data from the SIM. The black line is temperature. Over time, it increases. The yellow line is the energy absorbed by the surface over time that increases. And the blue line is the ice, which over time decreases, which means it melts. The graph on the left is showing what is actually happening with methane levels on Earth from 1880 to 2018. You can see that there is an upward trend in the levels of methane. The graph on the right is from the sim when methane was increased. Increasing methane did the following. Earth's surface absorbs more energy over time, which is the yellow line. Temperature is increasing over time, which is the black line. And the amount of ice on Earth's surface decreases over time, which is the blue line. The ice is melting. The claim is supported with evidence from the sim and matches the graph of current methane data. Increases in methane cause Earth's surface to absorb more heat, which causes the Earth's temperature to increase. This leads to ice on Earth's surface to melt. So claim 2 is supported. Claim 3, decreasing sulfur dioxide causes increases in Earth's temperature. So here we have a graph. Even though the sulfur dioxide graph has a lot of fluctuations, remember fluctuations are data that's going kind of up and down, we're looking at an overall trend. The overall trend from here to here, we could say that it probably stayed pretty even, but we see a definite downward trend from here to here. So from about 1970-ish to 2010, there's definitely a downward trend. There was an upward trend briefly from about 1950-ish to 1970-ish, upward trend, but downward trend in recent years. Again, x-axis had year, y-axis had parts per million for sulfur dioxide. When we look at information from the sim, we see that the temperature when we, actually it doesn't tell us what we did here, but this is when we decreased the sulfur dioxide, we saw that the temperature increased. The amount of absorbed energy had a slight increase. They're slight increases, but increases. And the surface ice actually decreased. So the graph on the left is showing what is actually happening with sulfur dioxide levels on Earth from 1880 to 2018. The sulfur dioxide levels have many fluctuations, but about 1960, you can see there is a downward trend, I said 1970, in the levels of sulfur dioxide. The graph on the right is from the sim when sulfur dioxide was decreased. Decreasing sulfur dioxide did the following. Earth's surface absorbed more energy over time, which was the yellow line. Temperature is increasing over time, which is the black line. And the amount of ice on Earth's surface decreases over time, which is the blue line. So this claim is supported with evidence from the sim and matches the graph of current sulfur dioxide data. Decreases in sulfur dioxide cause Earth's surface to absorb more heat, which causes the Earth's temperature to increase. This leads to ice on Earth's surface to melt. Even though we saw in the sim that decreasing sulfur dioxide can increase temperature, when we examine the data from the real atmosphere, which are on the graphs below, we see that sulfur dioxide started decreasing around 1970, and the global average temperature graph shows temperature increasing about 1920. So change to sulfur dioxide is probably not the main cause of our current climate change. So when we look at actual data, sulfur dioxide started increasing about 1970. We saw a decrease start happening at that point. I'm sorry, I think I may have said increasing, but it's decreasing. We're seeing a downward trend here. But when we look at global average temperature, the global average temperature has been increasing since about 1920. So sulfur dioxide could have had a part in this, but it's probably not the main players. All right. Which tells you that, well, let's continue on. A final claim with supporting evidence. Going by. Final claim with supporting evidence. Looking at our graphs, carbon dioxide, methane. Let's look at about 1920 when we just said that the global average temperature started increasing. Carbon dioxide at that point was increasing. By my husband going to work, my cat saying goodbye to him. And methane in 1920 had already started increasing. So the two major players probably are carbon dioxide and methane. Global average temperature from 1880 to 2009. Both increasing carbon dioxide and methane are causing temperatures to increase and ice to decrease. You can see in 3 graphs here that all are showing an upward trend over the same length of time. This is evidence that increasing carbon dioxide and methane are causing global temperatures to rise, which results in Earth's ice to melt. So the next question is, why is this happening? So the two major players here, we can conclude, are carbon dioxide and methane. The focus of this lesson so far has been to investigate why the Earth is warming. Let's see if the sim can be changed to make the Earth as cold as possible. We are going to decrease the carbon dioxide and methane and increase the sulfur dioxide. Okay, so going into the sim, I'm going to make sure that I am on Earth system. I'm going to reload it. I leave sunlight the same, reflectivity the same. I'm going to decrease carbon dioxide to 0. I'm going to decrease methane all the way to 0. I'm going to increase sulfur dioxide all the way. And our goal here again is to see if I can make the Earth as cold as possible. Ladies and gentlemen, you do not need to go into the sim. I am doing that for you because a lot of people are reporting that they're having difficulty getting into Amplify. So let's see if we can make the Earth as cold as possible. Look, the ice is increasing. Can I even pull up my graph here? Absorbed energy is low, temperature is low, ice is pretty high. So yes, this definitely does get the Earth pretty darn cold. All right, so there isn't any glow in the sim. If I were to close this, you don't see a glow down here for the absorbed energy. So there isn't any glow to Earth's surface. So the energy absorbed by the surface decreased, which is why the temperature decreased. So here, I think Amplify is really just trying to get you to understand that that temperature and the absorbed energy are related. And the temperature is dependent on that energy being absorbed. All right, the last thing you're going to do is summarize what you learned in today's lesson. Today, I learned, and you're going to tell what you learned in today's lesson, okay? For tomorrow's practice quiz, you can review any of the lessons that we've done so far, look at videos again. You're going to have the key concepts to work from, so I wouldn't stress too much about it. You should be able to apply those key concepts to the questions. Okay? Hope you all have a great day. And that's it for today's lesson. Bye-bye.